Turbo machinery, Pelton wheel tutorial number 3. A Pelton wheel system with two jets receive water supply from a tank. The delivery pipe length is 2 kilometers. The tank located 380 meters from the nozzle. Turbine rotates at 500 rpm and produces 5 megawatt. Loss head of flow in pipe due to friction is 8% from turbine head. Pipe friction coefficient is 0.06, CV is equal to 0.95, phi or the speed ratio is equal to 0.48, nozzle efficiency is 0.9 and overall efficiency is 88%. Determine the pipe diameter and the diameter of Pelton wheel. Before we could solve this question, I hope you could capable to draw a diagram like this based on all the parameters given in the question. We have a tank here, and this tank is connected with a pipe system like this. We have nozzle, and the water jet come from nozzle and hit the bucket in the Pelton wheel. And from the question here, we know that the water level is 380 meters, the pipe length is 2000 meters, and the friction coefficient or the Darcy friction coefficient here is 0.006. So we will use this to calculate the major loss of the pipe here. And then this question also gives us the nozzle efficiency, so means we need to calculate the minor loss that occur inside this nozzle, and then it gives the value of CV here, coefficient of velocity, is equal to 0.95, so means that when water travel from the nozzle, point number 2 here to point number 3, before it hits the bucket, so the friction is represent as the CV equals 0.95 here. Then the Pelton wheel rotates and produces power of 5 megawatts, and the overall efficiency is 0.88. First, we need to calculate the pipe diameter. From this diagram, we could say that we need to calculate the velocity of jet after the nozzle here. So it means if we have point number 1 at water level here and point number 2 at in front of the nozzle here, we could compare the energy changes here by using the Bernoulli equation. So the Bernoulli equation for point 1 and point 2 can be represented like this. So we have P over rho G plus V square over 2G plus Z, and at the outlet here we plus with the major loss. From the question, we know that the major loss is 8% from the gross head. So 8% from the 380 meters is 30.4 meters. So we substitute the value of 30.4 as the major loss in the Bernoulli equation here. We could get the V2 here, the velocity at point number 2 just outside the nozzle here is 82.81. However, we cannot use that 82.81 as our jet velocity here because this nozzle has its own frictions. So we need to calculate the water jet that comes out from the nozzle by using this equation. Because the efficiency of nozzle is 0.9, so we could calculate the velocity of the nozzle is 0.9 times 82.81, and it becomes 74.53 meter per second. So means after the velocity overcome the friction in the nozzle, so the velocity that comes out at point number 2 is actually 74.53 meter per second. Then the water jet will travel from point 2 to point number 3, and there is losses between point 2 and point 3 because we have CV here is equal to 0.95. So we could calculate V velocity at point number 3, V3, and it is equal to velocity of jet that hit bucket as 0.95 times 74.53, and we get Vjet is 70.80 meter per second. Then we could calculate the effective head at point number 3 here before the water jet hit the bucket by using this equation. V square over 2g. We substitute the value of velocity at point number 3 here, or the velocity jet that hit the bucket, and we could get the effective head is equal to 255.47 meters. Next, because we already know the value of speed ratio here, we could calculate the velocity of wheel by using this equation. U is equal to phi times Vjet, because we learned in previous lesson, phi here is equal U over Vjet. So we substitute the value, we could get the value of velocity of wheel is 33.98 meter per second. To calculate the flow rate, we could use the equation of overall efficiency, and we rearrange this equation. We could get Q is equal to power out divided by rho G, overall efficiency, and effective head. We substitute all the value here. We could get the flow rate is equal to 2.27 meter cube per second. Then, because we want to calculate the delivery pipe's diameter here, so we could relate the condition here with the major loss in the pipe. We know that the major loss is 8% from the gross head, and it is equal to 30.4. And major loss here can be calculated by using this equation, F L over D V square over 2G. Just bear in mind that L here is the length of pipe, so it is equal to 2000 meters. The D here is the diameter of the delivery pipe, and the velocity here is the velocity inside this pipe. Because we don't know the velocity inside this pipe, so we substitute the value of V here by the terms of flow rate. So we substitute the value of V with 4Q over pi d square, and we need to square it again here because at here the velocity is by the power of 2. So we substitute the value of flow rate 2.27 meter cube per second, and the value of Darcy coefficient of friction F here is 0.006, and we could get the delivery pipe diameter is equal to 0.7 meters. Next, we are calculating the diameter of Pelton wheel. In previous calculation, we know that the value of U is 33.98 meter per second. We substitute into this equation. I think you already know the origin of this equation. We substitute the value of U here, we could get the diameter of the Pelton wheel is equal to 1.298 meter.